we'll do an example here because it's more fun. There is one, probably more than one, but at least one analytical solution where somebody worked out with math a situation where the factor of safety is exactly 1. So if you have this 45-degree slope that's 10 meters high with these properties, factor of safety is exactly 1. If you're using this associated flow rule, remember I said you set the dilation angle equal to the friction angle, which is not realistic in reality, but it makes the math easy, so you can work out this thing has a factor of safety. So we can just do it. So let's just do it. So let's start FLAC2D. Let's make a new project. Put it wherever you want, but I'm going to put it in training stuff, day 1, FOS, X1. Right, so you see there's a solution directory, so if you get lost or stuck, you can always just go in there and open the finished model solution. But don't go in there now. Make a new project and call it, slope or something. We'll see if we can work through this in the 20 minutes we've got left and not have to rely on going to the solution. This is about as simple a slope model as you could possibly build. So I'm pretty sure we can do it. Got a new project. So I'm going to make a new sketch. So we'll drop down here, make a sketch set, call it whatever you want, slope. Close this view thing over here because it's not useful. And then up here in the little drawing tool, I'm going to choose Slope Wizard. Got a simple slope. Just need a rise of 10. 35 degrees is fine. Give it a run of 10. Depth 5 is fine. Left 5 is fine. And on the right hand side, we'll say 10. We'll say OK. So zoom in on this thing. Now, full disclosure here, we've been experimenting with ways to get the Slope Wizard to make nice geometries that will create structured meshes. And this is not it. So I had a theory that if we put these vertical lines in here, we would get nice structured meshes. Turns out that that's not really correct. So what we want to do here is actually delete this vertical line in the middle. We could just mesh this thing right now the way it is and get an unstructured mesh, and that would fine. It would still work. But just to get the best possible model that we can build here, let's try and build a structured mesh. So I'm going to delete this line, this middle line here. Just click it and press delete. I'm going to delete this little point on the bottom here. So click that and hit delete. So I deleted that line, I deleted the point. Now I have to redraw the bottom line and see it disappeared here. So I go over here and choose line. This tool here, line. And just redraw that bottom line. And now I've got a 1, 2, 3, 4, 5-sided shape here. So what I want to do is draw another horizontal line from the toe of the slope across to the other side here. All right. Yeah, I actually zoomed in a little bit here to draw that line so it would snap to the line and also to the grid here and have a nice horizontal. You could force it to be horizontal by holding down Control. Stay horizontal. So now we just need to mesh it. So I'm going to go up here to the meshing tool, and where it says auto size all edges blocks, I'm going to use a zone length of 1. Say OK. And go up here and say mesh all blocks. Boom. This is a little bit coarser than this one, but run it just for fun. I think this will actually run with the demo. This will definitely run with the demo version. Less than 1,000 zones. If we have time, we can come back and make it denser. But we're basically done with that. So we can create the zones. Press this little create zone button. Now I'm in the model pane. Yep. We could, let me go back to that. If I take away this line, it's going to think that this is a 5-sided shape. Because there's two, even though it's a single straight line, there's a point here. So it's going to say, oh, there's 1 side, there's 2 sides, 3 sides, 4 sides, 5 sides. So if you, even if there's a point on the line, even if it's a straight line, if there's a point on it, you gotta draw a line down. You see what I mean? So okay, so I'm going back to the model pane here. So here's where we can assign a constitutive model. So Control A to select everything. And go up to this rightmost tool and say assign a constitutive model. So here you can see all the constitutive models, but we're just going to go standard. Okay. And everything's still selected. So we go in here and say set model properties. And oh, this font's a little small. Hopefully, figure out what I'm typing here. Density 2000. Modulus 1E8. Modulus 3E7. Turns out the bulk modulus and shear modulus don't really matter that much. You know, when you do limit equilibrium, you don't even have to give a stiffness, right? You just give cohesion and friction. So I'm not super worried about the deformation, and modulus isn't that important. Okay. Bulk 1E8, shear 3E7, cohesion. This one's important. 1, 2, 3, 8, 0. So this is the value that this guy had to come up with to get this exact factor safety of 1, right? 1, 2, 3, 8, 0 for cohesion. Friction 20. I remember this is this wacky associated flow rule, so you say dilation 20. And we don't care about tension failure, so just put like 1E10 or some huge number. Okay, everybody got those values? Say save changes. I'm going to do one more thing here. I'm going to click this little A icon, assign group names to faces automatically. Uncheck the box for faces inside the model. Check the box for ignore existing group names, because all I want to do is define the outer boundaries, right? Okay, assign groups. And there we go. So we've got east, we've got bottom, we've got west. We've got 3 tops, but we don't care about that. Okay. And we're done with this. So I'm going to go, what I'm going to do here is I'm going to go file, save project. It says you want to save the model state. I say yes. And just call it like, I don't know, slope 1.